Nelson sent me a great question on our section 1.1 homework. So in this video, I'm going to go over this question. This is question number 16 on section 1.1 homework. So when you guys see a MyLab homework question that you want me to go over, you should be able to find a button that says help me solve. Actually, I think that's it. Help me solve this. Nah, I'm sorry, not that one. Where are you? How do I ask the publisher? There should be an option for you to send me an email, a link to create a ask my instructor. I'll take a look at it. I thought it was here, maybe not. But I should ask Nelson how he sent me this email. But I'm gonna go over these videos as I get them. So this one is about determining whether the value of c, so that the limit of f of x as x approaches 4 exist. Remember from class, for the general limit to exist, the left hand limit and the right hand limit should be the same, right? They should be going to the same place, and it looks like we're going to test the left side limit as x approaches 4 from the left and x approaches 4 from the right. You guys can do this in two different ways. I think the easier way is graphing it. I'm going to try to make sure that the graph touches. So I'll do it the easier way first, and then I'll show you how to do this just algebraically, okay? I'm going to go open up a Desmos graphing calculator. Desmos graphing calculator. This is a piecewise function, so we have a piece on the left. Okay, so I'll go ahead and type in x squared minus 7. And that is for x is less than 4. Notice that I'm using this fancy looking bracket to set the domain here, right? Okay, so the first piece is going to be a part of a parabola, but that stops at 4, and we will have an open circle at 4, right? All right, let me go ahead and type in the second one. Negative x squared plus c. Now, they never gave us c, so what we're trying to do is we're trying to come up with this c value. So I'll be random here. I'll be random and just pick any number. My birthday is March 13, so I'll put 13. Okay, I may be wrong, but hey, that's okay. And then I'm going to restrict the domain for x is greater than 4. The problem is now if you look at this, the left-hand limit is going to 9, right? As I get really close to this point, I can see that it's getting close to 9. Look at the y values. It's getting close to 9. Okay, right over here, that's where 9 is. But the right-hand limit, when I put a random answer 13, it's not going to 9. So what I see is this. I need to move this blue piece up a couple units so that they touch right there. Okay, so how about I change the 13 to like 20? Not quite there yet, right? How about I move it to 30? Oh, that was way too high. It's just way up there now. But I think I'm getting close. You see what I'm doing here, right? I'm just guessing and checking. What if I change it to 29? About 28, 27. Oh, maybe 26. I think I'm right there. Look at that. They're about to touch. Okay. For the limit to exist, the left-hand limit and the right-hand limit should be the same. I need to connect these red and the blue dot. So how about I change the c to 25? The answer is 25. Because now both the left picture and the right picture is going to 20. What's this? 9, the value of 9, right? So that's one easy way to do this. The answer is 25. But I'll show you how you don't really need a graphing calculator to do this. But when I saw this problem, that was the first method that I thought about because we did some graphical limit problems in class. But how would you do this? Oopsies, I'm getting a lot of emails today. How would we do this algebraically? Let me open up my notepad so that I can write down some work for you. I think it's actually much easier to do this algebraically, okay? All right, I'm just going to open up a blank piece of paper. A blank piece of paper. Here we go. Now, for them to touch, for them to be going to the same place, they have to be at the same point at the same time. So what I'm going to do is I'm going to set these to equal to each other. Okay, I'm going to set these to equal to each other. I have x squared. The first piece is x squared minus 7. The second piece is negative x squared. What's that? Plus c. But the problem is this. I have one equation, okay? But I have two different variables. I don't know what x is, but I don't know what c is. But hey, I know what x is. We want to make sure that they end up at the same place as x goes to 4. As we get infinitely close to 4, we want them to be at the same place. So guess what x is, okay? Plug in x equals 4. Okay, so then I will get, this will turn into what? 4 squared minus 7 equals negative 4 squared plus c. Now look, I only have one variable, c. I should be able to solve for this c now. So let's do that. This is 16 minus 7. This is negative 16 plus c. If I add 6, you know what, let me go ahead and subtract this. This is 9 equals negative 16 plus c. Add 16 to both sides. 9 plus 16 is 25. So that's how you can find the c value, by simply setting the top piece and the bottom piece equal to each other and plugging in x equals 4. But two different ways, but we're doing the same thing. We're setting it up. We're trying to find where they can connect, right? And they will connect if c is equal to 25. This was a very good question. So I'm going to go ahead and publish this and post the link to this video on Canvas, and I'll try to answer as many questions, answer as many emails as I can this week. But just let me know if you get stuck on a homework problem. Feel free to email me a link, okay?